Except as noted on current production versions of the Intersync servo, all of the test points and the adjustments are available without removing the overlays of the printed wiring assemblies. On older versions of the Intersync, the overlay panels should be drilled to make the adjustments and test points in this short procedure available. The overlay panels should normally be left on to assure cooling airflow. On older versions, an oscilloscope and/or vacuum tube voltmeter will be required for these adjustments, but on current -9 and -10 versions, most adjustments may be performed with the test facilities built into the system. The adjustments should be performed in the order indicated. The procedure assumes that the servo is operational. Allow the recorder to reach its normal operating temperature before beginning the procedure. At least 30 minutes warm-up time is desirable. The servo mode selector switch can be in the preset, playback external, the vertical, horizontal, or automatic modes. On the VR1200A and VR1200B, make certain that the Tektronix waveform monitor sync selector switch is in the external position. If an adjustment does not produce the expected results after a full turn of the alignment tool, check the following. Is the correct test point or waveform being observed? Is the screwdriver on the correct control? For instance, R21 on board 6 is drum frequency, R21 on board 7 is drum damping. Is the scope or waveform monitor being triggered correctly? Avoid errors due to screwdriver drift. Step 1. Turn the head override switch, the ready button, on. Set the meter selector switch on the servo meter panel to reference discriminator. Adjust R28 on board 2 for center on the meter. Alternatively, a vacuum tube voltmeter or oscilloscope set for DC voltage measurement may be connected to the test point 4 on board 2 and R28 adjusted for 0 volts. Average out any sawtooth ripple if using an oscilloscope. Step 2. Turn head override switch off and allow the head wheel to come to a full stop. Set the A-scope or the waveform monitor selector switch to the drum oscillator position. Adjust R21 on board 6 to minimize any drift of the 240 Hz square wave. To use an external oscilloscope, trigger external negative from test point 1 on board number 2 and observe the waveform at test point 3 on board 6, then adjust R21 board 6 as described before for minimum square wave drift. Step 3. Turn head override on. Set the meter selector switch on the servo meter panel to TAC discriminator position and adjust R61 on board 3 for center meter reading. An external scope set for DC or a vacuum tube voltmeter may be connected to test point 3 on board number 3 and R61 adjusted for 0 volts as an alternative method for this step. Step 4. The following step is routine only when the recorder is used for electronic editing. If you don't have an editor, it should not be required more often than every 6 months. In any case, it should never be done unless the drum oscillator frequency, step number 2, is set correctly. Turn head override on. Set the servo meter panel switch to record phase position with the editor either on or off. Observe that when the servo stabilizes, the meter pointer averages in the center white portion of the scale. If it lies to the right or to the left, remove the overlay on board number 6 and adjust R85 on board 6 until the pointer is centered on the meter. On a recorder with no editor, use a VTVM or oscilloscope connected to the test point 1 on board 3 and adjust R85 on board 6 for 0 volts. Again, if using an oscilloscope, you will note some sawtooth component on the DC. Average it out when reading 0 volts. Step 5. Turn the head override switch on. Set the A-scope or waveform monitor selector switch to capstan oscillator position and adjust R20 on board 13 to minimize any drift of the 240 Hz signal. If an external scope is going to be used for this step, trigger it from test point 1 on board number 2 and observe the waveform at test point 4 on board 13. Step 6. Put the VTR into record. Set the servo meter selector switch to the capstan discriminator position and adjust R1 on board 12 for a center scale reading on the meter. If using an external scope or VTVM, measure this signal at test point 3 on board 12 and adjust R1 on board 12 for 0 volts. Step number 7. This next adjustment, capstan oscillator trim, is routine only on an editor-equipped recorder and is of primary importance when using the assemble mode. Put the VTR into record. With VTVM or scope set for DC, observe the signal at test point 1 on board 13. It should average about 0 volts. If not, remove the overlay on board 13 and adjust R18 on the board for 0 volts. This quick 7-step procedure should be sufficient to keep your Intersync operational and within specifications. But if one of the steps doesn't look quite right, we suggest you go through the long procedure step by step. Both of these alignment procedures have been included with this tape. Some of our customers have followed the suggestion in the installation section of the VR 1200 manual regarding defeat of the servo capture range extension circuits. If this has been done on your recorder, steps 1 and 6 of the short procedure, the reference frequency discriminator and capstan frequency discriminator adjustments can be eliminated. When making a recording, always check the record timing. This is very easy to do. With the machine in record, put the monitor switch in the input video position with stability marker dots also displayed. Look at the vertical interval. The dot should be on the leading edge of the serration and the servo warning light should be out. With a correctly adjusted Intersync servo and with the head override on, lockup time in the automatic mode when playing back a tape made to SMPTE proposed standards should not exceed 4 seconds. Here are some things to check if your servo won't make it. After lockup, horizontal and vertical lamps on the main control panel both on. Observe the drum error on the A-scope or the waveform monitor. Adjust the horizontal stability controls 1 and 2 on the servo chassis for the smallest amount of ripple in the drum error signal. Make sure that the tracking control has been set for peak RF off tape. Loss of vertical serrations or equalizing pulses in either the tape or reference signals. Incorrect equalization or attempted playback on the wrong standard. Remember that proper operation of an electromechanical system such as this servo-controlled tape transport relies on correct mechanical adjustment as much as correct electronics alignment. For instance, unstable servo operation, as indicated by any large random excursions of capstan error signal during playback, may indicate the need for cleaning and/or tension adjustment of the capstan belt or adjustment of the pinch roller pressure. Check also that the pinch roller is clean, resilient, not highly glazed, and that it rotates freely. Incorrect take-up and hold-back tensions will also contribute to servo instability. Additional tapes in this series from the Ampex Training Department will describe correct mechanical adjustment and maintenance procedures for Ampex videotape recorder top plates.